reactant. A reactant means the chemical substances which are participate in chemical reaction is called reactants. Now, let me discuss about the products. What are products? Products means the chemical substances which are obtained during the chemical reaction or in the chemical reaction. During the chemical reaction is called as products. Simply, conversion of reactant as product. Conversion of reactant as a product is called as chemical reaction. Okay. In a chemical reaction, reactant and products are separated by a single head arrow mark. Single head arrow mark. For the example, a reactant gives rise product. It directs towards the product. It's clear. This process is called as a chemical reaction. Of course, some chemical reactions takes place in single direction or unidirection. Those chemical reactions are called as irreversible reactions. Means reactant gives only product. Now, in some chemical reactions, the conversion of reactant as product called as forward reaction. Children, it's clear, Nama? It's silent day pair.
Yes, sir. Yes, sir.
Okay. Forward reaction, simply expressed as a FR. Okay. At the same time, conversion of product as a reactant is called as a backward reaction. Or a reverse reaction. This is BR. Conversion of reactant as product is called as a forward reaction. Conversion of product to give back the reactant is called as
backward reaction.
Yes. Nature. Based on the nature of reactants, means reaction process. Chemical reactions are in two types. Based on nature of chemical reaction process. These are in two types. First one is a irreversible reaction. Irreversible reaction. Soumya, what is forward reaction? Soumya.
Backward.
The conversion of reactant to product.
Now, irreversible reaction, children. What is a irreversible reaction? The reaction in which it takes place in a unidirection. Unidirection. Okay, no? That it is a reactant gives only product, but product
Product does not give reactant.
reactant. Okay. Only forward reaction takes place. May occur in open or closed division. Right, children. Now, fast reaction. After completion of reaction. After completion of reaction. Okay. Concentration of reactant almost zero. Means completion of the reactant. And a reactant complete reactant concentration negligible. Only product concentration is there. Only product concentration is there. It's clear. Okay, fast reaction, complete in a finite of time. Complete in a finite of time. For the example, what I am taking, children, for this one, what I am taking? Carbon plus oxygen gives rise carbon dioxide. Magnesium plus HCl, 2HCl gives rise MgCl2 plus H2. Now, another example I am giving. NaCl plus NaOH plus HCl NaOH plus HCl gives rise NaCl plus H2. AgNO3 plus NaCl gives rise AgCl plus NaNO3. These are the better examples for irreversible reactions. Most of combustion, precipitation, or acid-base reactions are irreversible reactions. Now, magnesium, another example, magnesium plus oxygen gives rise magnesium oxide. It's clear. Children, it's clear now. What are irreversible reactions? The chemical reactions which occur or takes place in unidirection. That is only reactant to be converted as a product, but product does not give the reactant. Only forward reaction takes place. May occur in open vessel or in closed vessel. Fast reaction. After completion of the reaction, okay, no? The concentration of the reactants almost zero. Only the product concentration will be there. So completion of this reaction in finite of time, or it takes a finite of time to complete the reaction. This is. Children, anybody doubt, children, regarding this one? Ma,
No, sir.
No doubt, sir.
Right. Now, let me discuss about the irreversible reaction completed. Now, let me discuss about the reversible reaction. Vasvi, what do you think so about the reversible reaction?
Which takes place in both the directions.
Reversible reaction, which takes place in both directions. Both directions, children. That it is FR and BR. Okay. Next, reactant give the product and
Product can give reactants.
slow reaction. Slow reaction takes up infinity of time. Infinite time. Okay. Occur most of conditions in most of closed vessels. Closed vessels. In case of any gaseous components present. Right. Banu joined, na? Banu? Beginning of the class level at Talli.
Middle I have joined, sir.
Okay. Right. Most of closed vessels takes place are completing most of the occurring most of closed vessel. In case of any gases components are present. Right. Now let me discuss you. Now after chemical reaction means after chemical reaction there is both reactant and product concentration is there. Product concentration is there. Both reactant and product concentration is there. Both itself. Not only one, both itself is there. Right? Attainment of equilibrium state. So equilibrium state is the characteristic property of a reversible reaction only. It is not a characteristic property of irreversible reaction. Now, I am giving model examples for this one, children. Now, heating of hydrogen and iodine to give. ఇక్కడ చూడండి తల్లి both the directions double half a arrow marks ఇది equilibrium symbol ఇవ్వచ్చు both forward as well as backward both are positive. It's clear now that it is a reversible reaction 2HI. Now N2 plus 3H2 gives rise 2NH3. Now 2SO3 plus O2 gives rise 2SO2. 2SO3. This is SO2. This is SO3. It's clear, children. These are the reversible reactions. Heating of quicklime limestone, okay, to forming the CaO plus CO2. These are the better examples for reversible reactions. Children, it's clear now?
Clear, sir.
Yes, sir.
Now, what is the rate of reaction? Let me discuss now. Rate of reaction. Nothing but speed of reaction or velocity of reaction. Rate of reaction or speed of reaction. Speed of reaction or velocity of reaction. Velocity of reaction. Let me discuss. Then what is the speed or rate of reaction? Now the change in the molar concentration of molar concentration of reactants or products in a unit of time. Unit of time is called as rate of reaction. Rate of reaction. Now we may use that word, the two different words, rate of forward reaction and rate of backward reaction. What is rate of reaction, children? The change in the molar concentration of product or reactants in unit of time is called as rate of reaction. It's clear. Concentration change by time, that it is rate of reaction with reference to either reactant or product. It is clear. The change in the molar concentration of reactant or product in unit of time is called as rate of reaction. So this rate of reaction may applied to forward reaction or backward reaction. It's clear. In a reversible reaction, both is possible. Na? In a reversible reaction, both are possible. Forward reaction and backward reaction. It's clear, children. Let me discuss about the one more method example for this one. Now I am taking a vessel which contains water. This water molecule may evaporate like this. Conversion of liquid state molecule as a vapor based molecule is called as vaporization. Already we discussed in the liquid state, means states of matter, vaporization. Now number of vapor molecules to be converted in unit of time is called as rate of vaporization. Rate of vaporization. Now these molecules are condensed to each other, okay, na? That it is called as rate of condensation. In the initial state, rate of vaporization is much more greater. In any chemical reaction, initially forward reaction is greater. On going to the time, forward reaction will be decreases and backward reaction will be increases. Now slowly ivi associate అయిపోయి దీన్ని form చేస్తుంది. That it is starting the backward or reverse reaction. It's clear, children. In any chemical reaction, initially forward reaction is greater, backward reaction is slow. As going to the time, backward reaction is increases, forward reaction will be decreases. At a particular state, rate of forward reaction should be equals to rate of backward reaction. Such a state is called as equilibrium state. Clear? Yes. At which, for the example, ilage తీసుకుందాం మనం. For the example, ఏం చేస్తున్నా నేను? For the example, chemical process తీసేసుకున్నాం. ఒక vessel లో. Vessel, this is the vessel containing H2 gaseous plus I2 gaseous gives rise to HI. It is the characteristic property of reversible reaction. 2HI is unstable. It gives rise the product మళ్ళీ బ్యాక్ కి ఇవ్వడానికి ట్రై చేస్తుంది. అంటే ఇనీషియల్ గా వీటి కాన్సన్ట్రేషన్ హై ఉంటది కాబట్టి ఫాస్ట్ గా కొలైడ్ చేసేసి ఫాస్ట్ గా దీన్ని 2HI ని ఫామ్ చేస్తుంది. As going to the time its concentration is decreases na, then speed of the reaction is also decreases as going to the time. So as going to the time, forward reaction will be decrease. So at the initially its concentration is 0, means the backward reaction is 0. As going to the time, formation of HI started to decompose. As increasing its concentration, increasing the rate of for backward reaction. Okay, na? So it gradually decreases, it gradually increases. At particular time you are reaching, then rate of forward reaction should be equals to rate of backward reaction. Such a state is called as equilibrium state. Children, it's clear now?
Yes, sir.
Is anybody doubt?
No doubt, sir.
No doubt. Right. Equilibrium state. In a reversible reaction at which rate of forward reaction is equals to rate of backward reaction. Rate of backward reaction. Okay, no? In a reversible reaction at which rate of forward reaction is equals to rate of backward reaction is called as equilibrium state. Equilibrium state. Okay, a reminderable point at equilibrium state, the measurable properties like okay, concentration, temperature, pressure, density, color, okay, do not change with time. Do not change with time, or no change with time. Time is going, but no change in the color. The system approach to equilibrium state. Right, children? Children, up to this one, anybody doubt?
No doubt, sir.
So basically, this equilibrium state is fast static and dynamically. ఇంకవంతా డిస్కషన్స్ మనకి లేవు. డైనమిక్ ఈక్విలిబ్రియం అని చెప్తాం. సింప్లీ వన్ వర్డ్, డైనమిక్ ఈక్విలిబ్రియం. వాట్ ఈస్ ద డైనమిక్ ఈక్విలిబ్రియం? కెమికల్ ఈక్విలిబ్రియం ని అప్రోచ్ అయిన తర్వాత ఓకేనా, డైనమిక్ ఈక్విలిబ్రియం గురించి మనం డిస్కస్ చేద్దాం. వాట్ ఈస్ ద క్వాస్ స్టాటిక్ అండ్ మెటాస్టేబుల్ అండ్ స్టేబుల్ ఈక్విలిబ్రియం స్టేట్ లేటర్ అవి తర్వాత చూద్దాం. సో బిఫోర్ గోయింగ్ టు దట్ వన్, at the state of equilibrium, the measurable properties like that concentration, temperature, pressure, density, color do not change with time at equilibrium state. At equilibrium state, these measurable properties cannot be changed. So such a state is expressed as a equilibrium state. At equilibrium state, children, reminder, rate of forward reaction is equal to rate of backward reactions, but their concentrations may or may not equal. This is the reminderable point. The concentration of reactant and product may or may not equal, but their rates should be equal. It's clear. Now let me go to the concept. Now, equilibrium physical state or physical equilibrium based on process, equilibria in two types. First one, physical equilibrium, means equilibrium is in a physical process, is called as physical equilibrium. Second one is equilibria is a process observed in the chemical process, is called as a chemical Equilibrium. Children, it's clear now? But tell
Yes,
me.
sir. Yes, sir.
So, how many types of physical equilibria is exist? Okay. So, physical equilibrium means what is the physical process? Means equilibrium observed in or formed in physical process is called as a physical equilibrium. Right. Let me discuss now. Physical equilibrium. Physical equilibrium. Then what is physical equilibrium, children? Let me discuss. Physical equilibrium means the equilibrium is established. The equilibrium established in a physical process. Physical process. Then what is the physical process? Okay, now, during the process, there is a no change in the chemical composition. Okay, na? is called as physical equilibrium. Physical equilibrium. Right, children. How many types of physical equilibrium may be established? So that first one is equilibrium observed in observed. Equilibrium is observed in fusion. Fusion means solid two. So this equilibrium is established between the two physical states. Simply now solid to liquid. Second one solid to gas. Solid to gas. Third one is liquid to gas. Liquid to gas. Next, now equilibrium established in a dissolving of solid in liquid. Solid in liquid. Next, fifth one, dissolving of gas in liquid. It's clear. So one by one, let me discuss about the how the solid liquid equilibrium is established, how the solid gas, how the liquid gas, how the dissolving process of solid in liquid or gas in liquid. Okay now.
Yes, sir.
Right. Right here. Now solid to liquid equilibrium. Solid to liquid equilibrium. Now, the equilibrium is established between. The equilibrium is established between two different phases. Means the equilibrium is established between solid and liquid state. Solid and liquid state. Liquid state. So this is equilibrium in freezing or fusion or melting process. For the example, ice is taken, ice, which is a solid state, okay, means to be converted as a water, which is in liquid state. But as a molecular formula H2O, water molecular formula is also H2O. H2O solid to H2O liquid. So this is equilibrium in fusion, simply called as. Okay, it's clear, Sinan. So many examples are there. Okay, just one is enough. ఇంకా దీనికి మనం ఇంతకంటే ఎక్కువ టైం వేస్ట్ చేయలేము. నెక్స్ట్ టెల్ మీ చిల్డ్రన్ ఈక్విలిబ్రియం ఇన్ సాలిడ్ ఇన్ గ్యాస్. టెల్ మీ.
Yes, sir. Solid to gas. Camphor.
Yes, conversion of
Solid to gas.
solid to gas is called sublimation. So equilibrium established in the sublimation process, of course. Okay, now some compounds or molecules directly changed from a solid state to gaseous state. Deenki koncham explanation untali, let me discuss. So better example what I am taking, this is a closed vessel. Already I told you most of the conditions. Okay, now equilibrium is established in most of the closed vessels. This is the solid iodine, children. Solid iodine. Okay, this is solid iodine. I kept here. I fitted a manometer to this one. This is the level of mercury. This much. After 4 hours, I observed the same experiment. This is same experiment. Now, what I am taking, children, this iodine is taken here initially, which is a violet colored substance. Initially, no color appeared in these. Okay, this. Now, gradually starting the vaporization process, means sublimation. Now, these iodine molecules are going to this one, getting the vaporization process, means it's like this. So after a few minutes, a little bit okay, color intensity of violet color is appears. As going to the time, this mass of the iodine will be decreased. Intensity of violet color is increases. And going to the time, its intensity increases, reaches a maximum. After it is consistent. No change in the color intensity. And the pressure is also gradually increases, reaches a maximum. Then after it is not changing in the pressure, not changing in the color. Already I told you, children, the measurable properties like that pressure, color, density do not change with time. At this process, conversion of solid iodine to vapor state is called as vaporization. Later, this is forward reaction. For example, these iodine molecules in the vapor state may collide with each other to condense. This is called as a process, means condensation process. I2 condensation process. This is forward reaction. This is backward reaction. And going to the some time, both one iodine molecule is evaporated. At the same time, one iodine molecule should be condensed. One iodine molecule increased, one iodine molecule decreased, means condensation. So this process, in this situation, the system approach to equilibrium state. At equilibrium state, both rate of forward reaction and rate of backward reaction is the same. Now, I2, iodine solid gives rise iodine gas. Ammonium chloride solid gives rise ammonium chloride gas. Benzoic acid C6H5 COOH solid C6H5 COOH gas. Naphthalene camphor solid camphor gas. These are the better examples for exist is in the solid state to vapor state. This is called as a gas. Solid to gas, equilibrium state. Children, this is the remaining part of the equilibrium to be continued in the next class. Thank you. This is our class for today. Next we will meet by the next class. Thank you,
Thank you, sir.
children.
Thank you, sir.
Thank you, sir.
Thank you, sir.